Hi guys, welcome to video lecture number 4. Now that we've seen how models of the atom have changed over time, and because we've determined which model we'll be using to learn about chemistry, we're ready to talk about the periodic table of elements. Go ahead and pause the video so you can write the essential question at the top of your Cornell notes. So what do the periodic table and atoms have in common? Each element square on the periodic table actually represents one atom of that element. Remember in the last video when I defined models as something that represents something else? Each element square on the periodic table is a model of an atom too, because they contain all the necessary information to represent an atom of that element in the form of a visual model. The element square and the visual model are really the same thing. By the end of this video, you should be able to use an element square from the periodic table to create an atomic model, or do the reverse, be able to identify which element square is being represented by a visual model, just by looking at the subatomic particles that it has. Each element square on the periodic table has 4 important pieces of information. The nice thing is, on your reference materials, they're labeled just like the element square on this slide. All you have to do is remember what the atomic number and mass number actually mean. So let's start with the chemical symbol and name, then we'll review atomic number and atomic mass. The chemical symbol is a 1 or 2 letter shorthand way of writing the element's name. It's used in chemical formulas and equations, which we'll learn about in another unit. One important thing to remember about chemical symbols: if it's a symbol with 2 letters, like the He in helium, then the second letter will always be lowercase. The full name of the element can be found at the bottom of the element square. Again, the great thing about being able to use the periodic table on tests and in class is that you don't have to memorize stuff. You can just look it up. If you forget the chemical symbol for an element, you can find the full name on the periodic table. Or, if you don't know which element a chemical symbol represents, just find it and read the element name below it. Anyway, the chemical symbol and the element name will come in useful later on. But it's the numbers in the element square that allow you to draw a model of an atom. The larger number at the top is the atomic number. If you recall, the atomic number is the number of protons the atom has. Every element has a unique atomic number. Helium is helium because it has 2 protons, or an atomic number of 2. If it had an atomic number of 1, it wouldn't be helium, it would be hydrogen. If it had an atomic number of 3, it wouldn't be helium, it would be lithium. So you can use the number of protons an atom has to identify what element it is. When I'm drawing a model of an atom using an element square, I start with the nucleus, and I'd like you to do it this way too. First I draw the number of protons the atom has. What other subatomic particle is in the nucleus? We've got our 2 protons. That's right, neutrons. To find out how many neutrons are in the nucleus, you have to use the smaller number towards the bottom of the element square. It represents the mass number. Remember, the mass number is not the number of neutrons. It's the number of neutrons plus the number of protons. It represents the whole nucleus of the atom. One important side note: all of the mass numbers on your periodic table have decimals. See how helium's mass number is 4 3/1000ths? You can't have 3/1000ths of a neutron. The decimals represent something else that you'll learn about in high school chemistry, or maybe this year if we have time. But for now, be sure to round the mass number up or down to the nearest whole number. So 4.003 rounds down to 4. If you have a total of 4 subatomic particles in the nucleus of this helium atom, and you already know that 2 of them are protons from the atomic number, how many of them are neutrons? Must be 2, right? There really is no number in an element square that just tells you how many neutrons the atom has. If you're looking for neutrons, you have to do some simple math. After you round the mass number to the nearest whole number, subtract the atomic number from the mass number. 4 minus 2, and boom, you have the number of neutrons. Okay, the last thing you need for your model is the number of electrons. This is just as easy as finding the number of protons, because all the elements on the periodic table have a net charge of 0. The periodic table represents atoms in their elemental form. In other words, there are no ions on the periodic table, no atoms with an electrical charge. In other words, the number of electrons is the same as the number of protons, which is the atomic number. Now, when you put electrons in energy levels around the nucleus, you do have to do it in a certain order. The first energy level can fit 2 electrons. So for our helium atom, we're done, because helium only has 2 electrons. But if you're modeling a bigger atom, electrons 3 through 10 would go in the second energy level because it can hold 8 electrons. And electrons 11 through 18 would go in the third energy level because it can hold 8 as well. You have to fill up each energy level in order. 2 in the first, then 8 more in the second, then 8 more in the third. We won't really be too concerned with atoms that have more than 18 electrons yet. I just threw a lot of information your way. So let me give you a memory device to help it all stay put. ApeMan is a mnemonic that will help you sort of unpack all the information in an element square when you're drawing an atomic model. The A in ApeMan stands for atomic number, which equals the number of protons, the P, which equals the number of electrons, the E. The M stands for the mass number, minus the A, atomic number again, equals the number of neutrons, the N. When you're drawing your atoms, I'd like you to write out ApeMan, just vertically, like this. I wrote what each letter stands for, but you can just write the letters. If you prefer, you could write it horizontally with the equals and minus signs instead. After you write ApeMan down, just fill out the numbers beside each letter. The atomic number is 2. That means there are 2 protons. Since the net charge of all atoms on the periodic table is 0, that means there are 2 electrons as well. Before we write the mass number, don't forget to round it to the nearest whole number. Helium gets rounded down, but some of the elements are rounded up. The rounded mass number is 4 minus the atomic number, which is 2, gives us the number of neutrons, which is 2. Now we have the number of each subatomic particle for a helium atom, and all we have to do is draw the nucleus and the electron cloud correctly. Okay, let's use ApeMan to draw a few atomic models. Alright, let's use ApeMan to create a Bohr model of a lithium atom. I know it's a mixture between a Bohr model and a quantum model, but in this class we'll just call it a Bohr model. So I already have the element square and ApeMan written down vertically for us, but let's go ahead and unpack the information. The atomic number for lithium is up here, it's 3, which means the number of protons in an atom of lithium is also equal to 3, and because there are the same number of protons as there are electrons, we have 3 electrons in a lithium atom. The mass number down here for lithium, notice 6.941, when we round the mass number, it's actually going to round up, unlike helium. So it rounds up to 7. Our mass number is 7 minus the atomic number of 3. 7 minus 3 gives us 4 neutrons in one atom of lithium. So we found all of the subatomic particles that we need to draw this atom out. Now we just need to draw the nucleus and the electron cloud of the atom correctly. So let's go ahead and do that together. I've got a key up there for my subatomic particles. And let's begin with protons. The number of protons in the nucleus of a lithium atom was 3. So let's go ahead and draw out 3 protons. And the number of neutrons in a lithium atom was 4. So our completed nucleus has 4 neutrons and 3 protons. And then our electron cloud is going to have 3 electrons total. But again, we have to draw these in the correct order. So our first energy level can hold 2 of those 3 electrons, which means that lithium, that third electron, must be in the second energy level. Now, the one other thing that I might add to this model to make it a little bit better is the electrical charge of the subatomic particles. You know that protons are positive, but it never hurts to just add a plus sign to the protons so that you know they are positive, and a little negative sign by your electrons to show that they have a negative electrical charge. Not too bad, is it? Let's try one more. The second example that I'd like to work with you is building an atom of boron from the periodic table. So again, I've got everything listed and ready to go. The atomic number for boron is 5. And so that means we have 5 protons in this atom. And it also means that we have 5 electrons, since the net charge is 0. The mass number for boron is 10.812, so that 0.8 is going to round up to 11. So our mass number is 11 minus our atomic number of 5. 11 minus 5 gives us 6 neutrons in the nucleus of this atom of boron. Okay, now that we have gotten the subatomic particles that we need, electrons, protons, and neutrons, we can go ahead and draw the model of this atom. We've got our key ready to go. Let's go ahead and do this. We have 5 protons. They belong in the nucleus. 1, 2, 3, 4, 5. And we're going to have 6 neutrons. A lot of the time students think that neutrons and protons are always the same, because in a lot of atoms they are. But in the last 2 examples that I've given you, lithium and boron, there are more neutrons than protons. So never use a neutron to try and identify what element you're looking at. The atomic number, or the number of protons, is how you identify an element. All right, our electrons is the same as the number of protons. We've got 5 of them. If we fill out our electron cloud in order, 2 of those electrons will go in the first energy level. Let's make that a little neater. 1, 2, which means we have 3 more. They will go in the second energy level. 1, 2, 3. So there's our complete Bohr model of boron. Let's go ahead and add our electrical charges just to make our model a little bit better. Our protons all have a positive charge, and our electrons, let's remind ourselves, has a negative charge. Now, we can also do this in reverse. Let's take a look at what that looks like. Sometimes on a test or in class, you'll be given a model of an atom, like the one shown below, and you'll be expected to be able to identify what type of element it is using your periodic table and the acronym APEMAN. So let's take a look at this atom and fill out the information in reverse, and then I'll let you decide what element is modeled below. So let's begin by finding out the number of protons, electrons, and neutrons in the atom. This is really easy to do because we can simply look at the atom and count. We have 1, 2, 3, 4, 5, 6 protons in the atom. And we have 1, 2, 3, 4, 5, 6 electrons. So this is an electrically neutral atom. It is not an ion. The charges cancel out, so we can find this on the periodic table. Let's count our neutrons. 1, 2, 3, 4, 5, 6. So this atom has the same number of protons, neutrons, and electrons. All right, the mass number is the entire nucleus of the atom. It's the neutrons plus the protons. So if we have 6 protons and we have 6 neutrons, we'll work this in reverse. Our mass number is going to be 12 protons plus neutrons. And our atomic number, easiest one of all, is simply the number of protons. So we have 6. Now that we've filled out 8-man, take a look at your interactive notebook and the periodic table at the back and decide which element is modeled below. I'll see you next time.